Welcome to AI Frontiers, Computer Vision Innovations, exploring papers from July 21st, 2025 in computer science, computer vision and pattern recognition. Today's episode covers cutting-edge advancements in AI visual perception, focusing on the field of computer vision and pattern recognition, with insights from papers dated 2025-07-21. Did you know that artificial intelligence is now grouping objects like a curious child, based on how they move together when poked? This approach is inspired by human psychology, mimicking infant cognition for better robot interactions. Imagine a kitchen robot handling stacked plates as one unit, not random pieces. This breakthrough from recent papers could redefine machine perception. Stick around to explore how AI is evolving to see the world more intuitively. Welcome to AI Frontiers, where the latest research is synthesized. This episode examines 66 papers from the arXiv preprint server dated July 21st, 2025. The focus is on computer science, computer vision, and pattern recognition. The purpose is to unpack innovations in image and video interpretation, providing engaging insights. The discussion will cover a field overview, dominant themes, key findings, a standout paper, and a future outlook. This narrative is aimed at broad audiences, explaining concepts conversationally in a TTS-friendly manner. Computer vision and pattern recognition, often abbreviated as CV, involves AI processing visual data such as images and videos. It can be analogized to equipping a computer with eyes and a brain to understand scenes, not merely capture them. Key tasks include object detection, segmentation, which divides images into meaningful parts, and generative modeling. The significance lies in powering applications like self-driving cars, medical imaging, and facial recognition. Challenges addressed in today's papers include handling poor lighting, occlusions, and adversarial attacks. A dominant research theme is advanced segmentation and understanding of visual scenes, which involves breaking down visuals into meaningful parts, inspired by human cognition. For example, Venkatesh et al. Introduced Spelke segments for motion-based grouping, similar to how babies perceive cohesive objects. This can be metaphorically described as AI gaining a sixth sense for physical unity, aiding robot grasping. The technical concept centers on unsupervised segmentation. Clustering without labels, explained as grouping by simulated interactions. This theme overlaps with benchmarks for evaluating physical common sense in videos. Another key theme is generative models and their applications, particularly diffusion-based ones for iterative image and video creation, akin to clearing a foggy window. Examples include personalized generation with social feedback and subsurface modeling for industries. Robustness against adversaries and real-world chaos is also emphasized, metaphorically like fortifying a castle against sieges for secure applications. The technical concept involves adversarial transferability, where attacks work across models, boosting defenses via disruption of semantic and abstract features. This includes robustness in healthcare and finance. Efficiency and optimization form a core theme, emphasizing lightweight models and multimodal integration, blending vision with language or actions. Examples include token pruning in vision transformers and knowledge distillation for deepfake detection. This can be metaphorized as tuning a race car for speed on less fuel, enabling AI on devices like smartphones. The technical concept of few-shot learning allows adaptation with minimal data, such as quick medical segmentation. Applications extend to coherent video generation and anomaly detection in specialized fields. Key findings from the papers are presented as breakthrough stories. The C framework boosts video segmentation by 11.8 points, using conceptual thinking, akin to spotting friends in crowds. Safer enhances adversarial attacks on ImageNet, exposing flaws for stronger defenses in secure applications. TokensGen generates glitch-free long videos, revolutionizing film and training simulations. The lottery ticket hypothesis prunes deepfake detectors to 3,000 parameters while retaining 90% accuracy, combating misinformation. Sparse autoencoders uncover interpretable features in cancer models, improving trust in diagnostics. A pivotal study is Venkatesh et al. 2025, titled Discovering and Using Spelke Segments, which bridges psychology and AI for physical segmentation. The objective is to create category-agnostic groups based on motion cohesion, inspired by infant cognition. Methods include the Spelke bench dataset with annotated natural scenes and SpelkeNet, which predicts motions from virtual pokes. Statistical probing is used to cluster correlated movements in an unsupervised manner. This contrasts with label-reliant models like Segment Anything model, focusing instead on physics for robotics applications. In terms of findings, SpelkeNet outperforms baselines on Spelkebench by capturing physical priors. Quantitatively, it improves manipulation accuracy in 3D editing tasks. Qualitatively, it handles complex scenes, such as treating tangled objects as cohesive units. The unsupervised approach allows scaling to new domains without retraining. Highlights include better alignment with real physics, which reduces errors in grasping simulations. The significance of this work lies in shifting the paradigm to psycho-inspired AI for intuitive perception. Applications include safer robots and realistic AR/VR interactions. Limitations involve simulation inaccuracies in messy real physics. The human element is evident, as researchers drew from Elizabeth Spelke's infant studies, overcoming computational challenges. Broader impacts challenge the focus on semantic segmentation, fostering hybrid human-AI understanding. Future directions in AI vision can be analogized to a caterpillar transforming into a butterfly, evolving from limited models to those capable of intuitive reasoning about the physical and conceptual world. Multimodal fusions are expected, integrating vision with language and actions for empathetic robots that learn from videos. Efficiency will advance through optimizations, making computer vision suitable for edge devices. Robustness against biases and hallucinations will improve via ethical benchmarks. Hopeful advancements, such as psycho-inspired approaches like Spelke segments, promise applications in disaster prediction and personalized medicine. In conclusion, the episode has explored an overview of computer vision, themes such as segmentation, including Venkatesh et al.'s work, generative robustness, and efficiency. Key findings highlight leaps in adversarial defenses and explainable models. The Standout paper on Spelke segments advances human-like perception. These papers from July 21, 2025, demonstrate a field bursting with potential. A call to action encourages diving into these papers and sharing thoughts on what is next for AI mimicking baby vision. Stay curious with AI Frontiers for more research stories. This synthesis was created using AI tools, including GPT Grok with model Grok 40709 for content generation. TTS synthesis was handled via OpenAI for audio narration. Image generation utilized Google tools for visual elements. The content underwent review by a human expert to ensure accuracy. Note that some oversights may exist, and all references are provided for verification. Subscribe to the AI Frontiers channel for daily dives into AI research. The channel title is AI Frontiers. Get updates on cutting-edge papers, synthesized narratives, and future trends. Follow online and share insights to stay ahead in the AI revolution. In this podcast, we bring you the latest breakthroughs in computer science and AI straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer, this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.